Hi, and welcome back to part 2 of our chapter 18 chapter here. And in this part, we're going to be talking about relative risk. So, I think the book does an okay job talking about relative risk, and I think I'm going to add a little bit more to it for everybody. So, what is relative risk? So, relative risk is comparing the probability of developing a disease based on the presence or absence of an exposure via a measure of association called the relative risk. So that's what the relative risk does. It's giving the probability of developing a disease based on presence of exposure or absence. So the way they calculate relative risk is relative risk of I is equal to the proportion of I over the proportion of 1. And that is okay, and we're going to talk about that first and then move on to what I think is an easier way to do relative risk and easier way to calculate also odds ratio and just the way to do it moving forward. So when we have relative risk, here is a table. So here's our table from before that we were talking about with smokers and education group, and we were talking about the prevalence, and then the relative risk is what we're calculating next. So an example at the very bottom here of calculation. So here we have relative risk 2, which is p sub 2 over p sub 1 equals 0.211 over 0.244. So you can see this as here's your p hat of 1, and here's your p hat of 2, and you take p hat of 2 divided by p hat of 1, and there's your relative risk of 0.888 or 0.88. And I think that's definitely one way to do it. I definitely think there are easier ways to look at this example, and one of the ways I would like, I think, to look at is really break this down into a 2x2 table. Instead of doing our 5x2 table, breaking this down into more of a 2x2 table. And when we have 2x2 table, a great way to always remember how to list events, especially when we're dealing with diseases in epi, we'll always put, if you just remember one thing always put disease on top, and then your exposure on the side. I think this is one great way to always remember how to go. You can always put the or E as the explanatory variable and D as the response variable, right? What is the response? The response might be a disease, right? So that's the way I always remember. Disease goes on top. If you remember right, you'll be in great shape. And another way to look at 2x2 tables is to actually letter the tables, where you make this A, B, C, D. And so instead of having all this other stuff, you do A, B, C, D, and then when we're doing relative risk, an easier way, I think, to remember the formula for relative risk with A, B, C, D is A divided by A plus B over C divided by C plus D. Now, some of you might think that this is not easier or not. I think it's easier. It's the way I was taught how to do relative risk. It's very similar to what you're doing up here, right? You're taking A over A plus B, which is the total, right? And you're getting your P equals 1. And then you're taking your C over C plus D total, and your P sub 2, and then dividing them out. You can do it this way or the other way, and you'll end up with the same answers as before, and that's the way I've always was taught to do relative risk. And so then you have this. And so one thing I also think the book doesn't go into great detail about is talking about, okay, so you have this relative risk value, but what does it mean? So interpreting a relative risk value, so here we have, if you have a relative risk of greater than 1, the exposure is said to be harmful. So you have a harmful exposure, so your risk is not only greater, it's harmful to you, right? Easy example, the longer you are in the sun without sunscreen, the risk of developing a sunburn is higher, and the risk of having skin cancer later in your life is also higher too, so your relative risk would be greater than 1. If your relative risk is equal to 1, there is no effect. It's neither protective nor harmful. And if your relative risk is less than 1, the exposure is said to be protective. So if you ever see RR values, if they're greater than 1, it's harmful. If they're less than 1, the exposure is said to be protective. It's protective in value. And so here's a little chart to help explain that, hopefully a little bit better for you. And then here we have odds ratios by an R/2 table. So this is the odds of event occurring, a success to failure. So this is kind of like probability, like odds, probability. So A sub I over B sub I gives you your odds. And then you have odds ratio, which is the association of exposure level in your I group in an R/2 table. And so here's your odds ratio is A of I over B of I over A1, B1. So the interpretation of odds ratio is similar to relative risk. Example, the odds ratio is approximately equal to 1 implies no association. You can go into the chapter and see more details about that, but same kind of rules apply there. And here we have 18.4, which is our odds ratio, education, smoking illustrated. So here we have an example written out for us all here. Here we have the odds of smoking in group 1. So we have 12 over A over B, and here's your odds of smoking. So that's what these categories are. It's just yes divided by no. The odds of smoking in group 2, so A sub 2 over B sub 2, right? So this is for row 2, and you have your odds of thing. And then when you want to calculate your odds ratio, you take your A sub 2, or your odds of 2 and over the odds of 1, and you'll get your odds ratio. So it's very similar setup, just like relative risk, just a little bit different. One of the ways I always did it too, if you want to use the our 2x2 table using our A, B, C, and D, since it's not covered in the book, that's why I'm writing it down. If you want to, for an odds ratio, you can do A times D over B times C, and that's how you can get your odds ratio. That's also kind of covered in the back a little bit more, expressed like this, but that's another way to determine your odds ratio. So here we had the efficacy of echinacea. It's a randomized controlled clinical trial of pitted echinacea versus placebo in the treatment of upper respiratory symptoms in children. The response variable was severity of illness, classified as mild, moderate, or severe. So here you have your two groups. But it's you have two groups, but we actually have three different potential outcomes. You have mild, moderate, and severe for the placebo and echinacea, and then you have your column totals, and then your row totals off to the side. And then this guy right here is kind of like, if you want to call it, your grand total of everything. So here we have conditional distributions. So with our conditional distributions are row percents. And we have row percents are calculated to determine the incidence of each outcome. So when we want to calculate the incidence of each outcome, remember it's that particular value we're looking at over the total. So an example of calculations, you have the top right cell. So we have the top right cell. We're going to go back. You have severe as your 48, right? That's where we get this 48 from. Divide by 392, which is the total, right? So that's how we determine the prevalence of a certain area. It could be incidence too, depending on the time frame you're looking at. So you have 48 divided by 329 times 100%, and you have 14.6%, and that's what is expressed here as the row percents calculated for. So they're saying this incidence of each outcome. And then inclusion, the treatment group fared slightly worse than the control group of 14.6. Of the treatment group experienced severe symptoms compared to 10.9 of the control group. So what they're doing is they're comparing the severe and from the control to the actual group they're comparing it to, the echinacea group, and they're saying that the treatment group fared slightly worse than the control group. The group experienced severe symptoms compared to 10.9 of the control group. So moving on, now we're going to head into the chi-squared test of association. Once again, this is kind of like the new test. I don't think odds ratio and relative risk are a crazy thing to look at. Maybe with bigger tables, it might be a little bit harder, but if you kind of break them down into just 2x2 tables, as the chapter implies, and just break out what you're looking at, then I think they become a lot easier to look at. The next part here, we're going to be going to chi-squared. Yes, it's pronounced chi-squared, test of association, where I think, as you see here, I think you'll really like the hypothesis scenarios and how we state all this stuff. And this is also called the fitness of good test. But I'm going to stop the video here so we don't run out of time.